Hello everyone, in this video you will be learning about convolution operation and facial expression recognition using convolutional neural network. Convolution performs the element-wise multiplication with the kernel. The kernel or filter is a small vector filled with randomly generated values. The receptive field is the partial region of the input data that the kernel is beholding. The kernel moves with the number of steps called stride, and the computed values are summed up producing a feature map. This shows an example of convolution operation with input vector of size 5 by 5 and the kernel size of 2 by 2. And what it does is that 2 times 2.3 times 3, 5.2 times 1, 1.6 times 1, and 0 times 2, and sums them up producing 13.7, and the kernel is going to move one position right, and the position how many positions to move is called stride, and in this case the stride is 1, and this is the receptive field because it's the region that the kernel is currently seeing, and the same process and is performed and producing 19.2, so it multiplies 3 times 5.2 and 1.6 times 1 and 0 times 1 and 1 times 2 and sums them up, and this process is repeated, and by moving the kernel one position right until the end, and the output vector will be filled, and the final output vector is called feature map. Convolution neural network CNN is a network that uses convolution operation, and we'll use CNN to create the facial expression recognition model. For good performance, the CNN requires extra operations like rectified linear unit, max plane, and the fully connected layer for final prediction. And the fully connected layer is downsampled to the number of labels, and in this case it will have 4 units. And the last layer is usually followed by softmax function that rescales the logits to range from 0 to 1, and the logits are another name for the last fully connected layer, for the output units of the last fully connected layer. And the loss function calculates how close the output representation is to the actual emotion label. So in this case, the input data is happy face, and if the training is bad, then the loss is going to be high, representing the learned output representation is far from the happy emotion. And if the training is good, then the loss value is going to be low, which means that the trained output representation of this happy face is close to the happy emotion. So the goal of this training process is to minimize this loss value to make the input data close to the corresponding emotion label. So let's create a model, and if you have a Google account, then you can first log in, and if you click Google Apps, then you can go to Drive, and let's create a new folder, and let's name it as FAR create, and double click, and if you right click on your mouse, then you can see more option, and if you see right, you can see Google Collaborator here, And if you don't see it here, then you can go to connect more apps. Then if you type collab and hit enter, then you'll see collaboratory here, and you can click this and install it from here. And because I've already installed, I'll close this. And once you've installed it, then you can see it in the more and Google Collaboratory. Click this, and then it's gonna create a workspace for us. And let's name this as FVR test. So first, what we need to do is we gotta download the data, and popular facial expression recognition data is called FVR 2013 Kaggle, and if you type in Google, then you'll see link, and if you click, then you go to this page and you can click this download button. And for the time sake, I've already downloaded, and you can decompress the downloaded file. And if you go into the folder, and you can see train and test. And because we are doing practice, I'll be simple. And if you go to train, and you'll see angry, disgust, and fear, happy, neutral, sad, surplus. And let's go to drive again, and we'll uh, add our data in this folder. So let's create a new folder. Let's name it as data. Create, and go in, and you can actually um, press this and drag down here, and it's gonna upload this folder. But because there are many data, many number of data, so it takes quite long time to upload all these images. So we will select only 100 images, and we'll start from binary classification and to recognize happy, either happy or sad, and we'll move on to multi-class classification of classifying more than 3 emotion labels. So we'll start from recognizing whether it's a happy face or sad face. Then let's create two folders. One is happy, and another one with sad. And go into happy, and if you um, go to the downloaded folder, and let's click happy, and let's select 100 images from here, and drag down, and it's gonna upload the selected 100 images. And let's go back to data folder, and let's go to set folder. Now let's go to train folder and click set, and let's select 100 set images. And drag here. So it's gonna upload um, the set images, and let's wait a bit. Let's check whether the happy images are uploaded properly. 50 items are uploaded, and let's go to data, go to set, and now I think all items are uploaded. So let's go to the workspace, the notebook, and let's read the data first. And to mount the drive, then we gotta use a command. And here, this is a project that I've done earlier. So this is speech emotion recognition. And if you go up, this is also the Google example. So this command mounts the drive and copy this and paste here from Google.collab, import the drive, drive.mount, content drive. And to execute the cell, shift plus enter, press. Takes a while. So connect to Google Drive and click and down, allow. So to check the directory that we have saved our facial images, then if you see here on the left, you'll see an icon like this, and it's called files, and click this. And if you click, you'll see drive, and click, then you'll see my drive, FAF folder, then data, then you'll see happy and sad. Let's copy this path, data path, copy path. So what I've done is that I've clicked this, and you can see copy path option. And let's write root path is R, paste. So this is the data folder, the path of the data folder that has happy and sad images and emotions. And if you go up over your mouse here, then you can see plus code option. Then click this, and let's import OS. And if you shift enter here and OS the list directory, root path, shift enter, and emotions, shift enter, then you can see happy and sad, and delete. And for emotion, in emotions column, if you print emotion, it's gonna loop this list and fetch one emotion and print the emotion. Then in the emotion folder, we have another images. So what we need to do is that full path, we need to designate a path using os.path.join root path, comma emotion. And if you type full path, full path of happy and sad directory. And again, if you want to see the images in happy emotion in happy directory, then you can again use this list directory. So items, I'll name it as images is with the list directory emotions. And if you fetch one image by one, one by one per image in images print image, uh, so it should be not emotions. Emotions is a list. So what we need to pass is the full path, the path of the directory. So shift enter. So you see the images. So um, label. So we need to add these images to our train data. So let's prepare a list called train list. Actually train x and train y. So in train x we'll have a list of items that for the images, and in train y we'll have the corresponding label. So train in train x, let's add, we gotta actually pass the full path. um, the let's name it as full path again. Let's name it as image path with the path that join. um, Full path comma image, and let's check whether it's correct, image path. So here we can see the full path of the where the image is, and because we the this is not in numbers, so we need to convert this image to a vector. So to convert image to vector, we can use cb2. So let's go up, import cb2 and shift enter. And if you image array cb2 the image read, uh, image path image array, um, I can't actually remember what the command was. So in this case we can search um, how to cb2 image read. I think the command is image read, so I am read. So go back, and image array is cb to the image read. So you can see the array, and if you want to check the shape, you can type shape. So the shape is of 48 by 48 by 3. Actually, I don't want to loop all over, so if you type assert false, um, it can finish, at this line. So the image shape is 48 by 48 by 3, and this 3 is the number of channels, and image is composed of red RGB values, red, green, and blue. However, because this is the grayscale, actually we need one axis, but just usually because we deal with 3 channels, um, let's just do with 3 channels. So um, delete, and we'll add this image array to our train x list, train x append image array, and the corresponding emotion is the emotion. So if you print emotion, uh, let's shift enter. So here we have said for the corresponding image, and if you go up, we first have the happy and for the corresponding image. So you map the image to the corresponding label for training, and this type of training is called supervised learning because you map the input vector to the corresponding label, and this process of learning is like um, teaching a baby to recognize object. So suppose a baby starts to recognize objects, and to teach the baby, the baby's mom is going to show an image of tiger and tell him that this is tiger, and show another image of tiger, this is tiger, this is tiger, and show another image of dog and tell the baby that this is dog. And through this process of matching the concept of the object to the image, visual image, the baby starts to recognize, discriminate what the difference between tiger and dog. And this is the process, this same process is for the supervised learning. So the what we are doing is that we are telling the machine that showing the image, happy image, this is happy, show another image of happy, this is happy, and show another image of sad, and tell the machine that this is sad image. And through this process, the machine starts to uh, differentiate the between the happy emotion and sad emotion. So let's continue, and we need the label. We added the image to train X, and we will add the label to train Y, the append um, emotion. So if you print uh, train Y, let's print the labels. So happy, 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 and sad, sad, sad. But note that the computer cannot understand word, so we need to convert it to a number. So to convert it to a number, uh, let's through labels happy. Rather than doing it like this, that we can um, in where was the because here is root path. Um, because we have the emotion categories in emotions. So what we can do is that if you print down here emotions, the index of sad, then it's gonna return 1. And if you say emotions, it has happy and sad. And because sad is at index 1, and note that the list index starts from 0. So if you pass happy, it's gonna return 0. So we can use index method down here, emotions, the index of the current emotion, and enter, and we have 0, 0, 0, 0, and 1, 1, 1. So we have prepared uh, our train X and the training image and the corresponding labels. And next, what we gotta do is that we need to convert the number of categories, the label into categories, and we call it as one hot encoding. And actually, I'll skip why we need to one hot encoding, but for the time's sake, I don't wanna go too deep. And I'll show you how to do one-hot encoding, and you can do it easily with um, Keras Keras library. Import from Keras details, import to categorical, enter, and train y to categorical, train y, and if you print train y here, it'll convert it to 1, 0, 1, 0, 1, and down here um, up go up 1, 0, 1, 0, and 1, 0 represent the emotion at index 0, and 0, 1 represents the emotion at index 1. So the corresponding emotion at the position is going to be marked with 1, and the rest of them all set to 0. So this is called one-hot encoding. And if you call to categorical, it converts the list to numpy, from what I remember. So let's convert only trainx to numpy array, because when the model is trained, if you use Keras, actually it deals with numpy array, so you cannot pass list as your input data. So np.as array, you can convert it to array, numpy array from list train x. So if you go up, if you declare with this two brackets variable, then it declares a list data type. And to convert to numpy array, you can use np.as array. So shift enter. Let's go up. I think I haven't yet declared numpy, so let's declare import numpy as np, enter, and enter. So go down and let's check the shape of train x the shape, comma train y the shape. So it has 200, 48, 48, 3. So remember we had 100 images for happy and 100 another 100 images per set. So the they in the total number of images is 200. So we next what we gotta do is that we pass this input data to the model, and the model is gonna train. And earlier I've uploaded speech emotion recognition model, and we can use the same convolution operation for training our model. So you can copy this bit, Control C, and let's paste it here. And the shape, it's because now 48, 48, 3. So shape, you can define the shape as 48, 48, 3. And convolution, let's remove this padding. And we'll use kernel size 3. So let's first create one convolution block. So convolution and relu. X is activation relu. X is convolution. Let's do max pooling. X max pooling. I cannot remember how I did max pooling. And you can again max pooling Keras. You can type max pooling Keras. Go to this link. So it's max pooling 2 dimension. Copy, paste. For pooling size, let's define it as 1 by 1 and remove this. And we need to flatten to apply dense layer. This is the fully connected layer. And at the last layer, we'll have softmax function. Actually, pool size, let's define it as 2 by 2. And stride is 1. Padding valid, let's remove this. So if you go to the documentation, we have this in Keras, the layers, the backspline. So copy this, go to this block, and if you go up, not let's define them here. Paste it here. So from Keras dot layers, import backspline to dimension and convolution. Because we are dealing with two-dimensional, we'll use convolution 2 dimension. 2D, comma, enter. So inputs, input, we also need to import input as well. Enter. Convolution 2 dimension and activation as well. Enter. And flatten as well. dense layer. I forgot dense layer. Uh, flat. Um, let's go up. So, what I've done wrong here is I didn't pass the tensor. So, flatten to compute this x, it understood it as an object. So, what we gotta do, we gotta pass this tensor x and shift enter. So, now it's all done. And what we gotta do is that go here and you can use this model, Ctrl C, copy, and go down here, paste. So model is from maybe import it from Keras the models model, and we need to compile. And because we are doing binary classification, we change the loss as binary cross entropy, and we'll use optimizer, Adam optimizer, and accuracy per matrix fit. And if you go up, we define train x for the training image and the train y for the corresponding labels. Let's go down. Train x, train y, and we need one more validation data. So what it does is that it validates the training data based on this validation data. So the accuracy is calculated on the validation data for evaluation. So we can use train test split down here. Let's split train x, train y, test x, train y, test y is then from sklearn the model selection, import train test split, and let's call train test split function train x, train y, test size. Let's use 20% for test size, and random state ensures make sure that the split ratio is same for for another trial. So random state set to 7, shift enter, and let's check whether they are split where train x the shape, test x the shape, train y the shape, test y the shape. So 160, 40, 40, 3 test image, 40 images, 40, 40, 3, 160 images for train labels, and 40 images for test image test labels. And let's go down and let's validation data test x test y, Apple 7, and because we don't have much data, let's set the battery size to 16. So let's start training. Shift enter. Um, 16,8. So what is wrong is that if you do flatten, when you did flatten here, um, if you type alt plus enter, then you'll have another block down here. So alt, and let's copy it and move it to here. Um, Remember, if we go to the slide for the final layer, we need to have the same number of units as the labels because we had 8. What the error was that we had more categories than the labels, so we need to change it to 2. So let's copy it here again and um, remove this, enter, and shift enter, and let's try again. Now the error is fixed, and we can see the validation accuracy is around 65, not too bad. And to let you know, the FVR 2013 data is very noisy, so um, even the recent model, recent state of art model performs from what I remember from the last time I checked is around 75. I remember it was less than 80. Um, so validation accuracy of 62 is not bad. It's kind of like doing quite well. So let's go up. So this time what we have done is we are recognizing either happy or sad emotion, and let's try to recognize more than 2 emotions. So let's go to the drive and go to data folder, and let's create let's go to train, and let's add fear, surprise, um, fear, create, and go to here and select 100 images, and actually the images don't have to have the same number of images with other emotion categories. So maybe this time we can choose 92, add it here, and let's go to data folder again, and let's create surprise, create, and let's choose for surprise, let's choose 60, maybe 64. Drop here. So let's go back to our notebook and go up, and um, enter. Let's start from the first cell, and one thing I forgot, to accelerate your training process, you need to change the runtime. Go click this runtime and change the runtime, and if you click select GPU, then the training process is faster. And you may not see the difference because the training data is small, but if you have um, many training data, like more than um, 10,000, then you probably notice the difference in speed. So if you once you change the run type, and you need to rerun, shift enter and reconnect to Google Drive. And let's keep going. So see, this time we have happy, sad, fear, surprise, four emotions because we created two more directories. And in this case, if you pass fear, then it's gonna return 2 because it's at index 0, 1, 2. Enter, and again shift enter, and this time you see the um the total. Let's wait a bit because it's taking a bit to read the data. So to go back, if you see the overall architecture, we have convolution, ReLU, max pooling, and if you see here, um, we have convolution, ReLU here, and max pooling here, and we are having only one block, and you can add more layers, and the more layers you have better feature representation, which means that the model is gonna perform better. But um, if you have too many layers, then it's gonna overfit the model, which means that the model is not model's performance is going to degrade. So you need to balance in between, not too small layers, but not too many layers. But the optimal layer, it's usually chosen by empirically. It's by empirically checking, adding more layers, checking the accuracy, and removing some more layers, checking the accuracy. So through this process of adding layers and removing the layers, you check the accuracy and you try to find the best number of layers. So the reading data all finished. So this time we have 356 total images. So shift enter, enter, and shift enter, shift enter. So this time 284 for our training images and 272 for test images, and shift enter. So what it says, value error logits and labels must have the same shape. Received 9,2 versus 9,4. This time we have four categories, so we need to change. What we need to change is this bit. Is we change it to 4 and rerun. Um, but before we run this, what we need to do is that we need to change the loss to categorical cross entropy because we are dealing with more than two values. So shift enter again. So as the model tries to discriminate more than two emotion categories, the model performance degrades. And let's try to add more layers and see if it um, if it affects the overall model performance. So um, let's convolution. So this 32 means the number of filters, and if you let's add copy this. Let's use max pooling only at the last layer. So copy and paste, and 32. Let's double this. 64 by 3. Convolution, ReLU convolution. Um, you need to pass the output tensor of the activation ReLU, convolution, ReLU, and max pooling, and flatten, and dense layer 4, activation softmax, enter, shift enter, shift enter, shift enter. Let's check the so you can see last time we had around 33 as yeah, maybe slightly better than last time with 2 more layers. Um, yep. So this is yeah, this is the end of my tutorial. So I'll finish off by explaining what ReLU and max pooling does. Let's go up. Excel. So if you have 3, 4, 1, 2, 1, 3, minus 3, minus 2, 1, minus 7, 7, 4, uh, minus 5, 3. And let's suppose this is the output feature. Uh, let's have one more column. 3, 1, 1, minus 1, 2, 2, minus 3, 4. And so let's suppose that this is the output feature map. And if this is the output feature map, uh, and if you perform ReLU, um, if you um, if you ReLU, then you remove the elements less than 0. So set these values to 0, 0, 0, 0, 0, and if you do max pooling with stride 2, then at this region um with kernel size 2 by 2, then it's gonna extract the highest number, maximum number. So in this case, because it's 4, so 4 4 is extracted out. And if the stride is 2, then it goes this bit, and now 3, and here the 2, and goes down, and 7 here, and 4, and then um this in this field it's 2, the maximum number is 2. So to classify this fully nth layer fully to flatten is applied, so they are flattened like 4 3 2 7 4 2. And as I mentioned earlier, when there are two categories, if you do fully connected FSC, if you apply FSC layer is unit 2, then they are projected to maybe 4 or 1. So what fully connected layer does is that it performs um, linear transformation, performs dot product, and according to the calculation, it will have any value like this, or 4 1, or 1, maybe 1a. And through softmax, these values are rescaled to range from 0.2, maybe 0.8. Then what it means is that the probability of happy is 0.2, and the probability of being sad is 80%. Then the model um, output selects sad for the predicts sad emotion for the given image. Yep. So I'll finish off here. Thanks for listening. Goodbye.